Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. We're here at the Tri-State Nutrition Conference 2025 in Fort Wayne, Indiana, and we're reviewing some presentations that's taking place this week. The one we're going to review now is called Practical Steps to Improve Diet Digestibility, and that's done by Dr. Jeff Firkins from The Ohio State University. Jeff, welcome. Did I put
Thank
enough
you.
emphasis on that?
Yeah, I think you did put enough.
Well, Jeff, before we get started, what I'd like you to do is just for the folks out there that may not know who you are, just kind of give us some background about who Jeff Firkins is.
Okay, well, I'm originally from Illinois,
Yeah.
so I've met some people who are nearby where I'm from. I went to the University of Illinois and did several degrees there. And then I've been at Ohio State since 1987, 1 month actually before Bill started there.
Wow. Yeah, excellent.
But he's older than me.
Yeah.
Well, my favorite game to play, and I'm just going to do this now, is Jeff, what year did you start at Ohio State?
1987.
And what year did you start?
88, January of 88.
1 month
I
different.
just like to point out that I wasn't born until 1996. And I just want to drop that in there. Because when would you have been born, Laura?
1993.
There we go. Yeah.
Oh, wow.
Just remember, Dr. Firkins votes on tenure, so just remember that.
So, Kirby, while you've got the floor, why don't you tell the folks who you are?
Yeah, my name's Kirby Krogstad, and I've been on faculty at Ohio State now for just over a year. Before that, I did research at Michigan State with Dr. Bradford and investigating inflammation, animal health, and nutrition. Then I spent time at Nebraska before that with Dr. Konanoff, and I'm a native South Dakotan, so I'm a jackrabbit at heart.
Yep. Good. Well, thanks for joining us once again.
Thank you.
Laura's going to be my co-host today. Laura Nihus is a newly minted Balchem employee from about 6 months ago, right?
Yep.
Laura, introduce yourself to the audience.
Yeah, my name's Laura Nihus, and like Scott said, I started with Balchem in December, so not too long ago. I've been getting caught up to speed and doing lots of podcasts. I've been in industry a few years, but prior to that, I did my PhD at University of Illinois and looking at rumen-protected amino acids during transition period. And prior to that, I actually was equine nutrition for my master's at Kansas State University and resident of Florida. So
Okay.
always coming to the cold weather.
Yeah. And so what do you do for Balchem?
I am technical services specialist at
And
Balchem,
covering what territory?
covering the East Coast. So covering the whole East.
All right, good. And then Dr. Bill Weiss. Bill, thank you for joining us once again. Real quick,
You already know
we know how old you are.
Yes, you do. And I worked there for about 35 years, retired a few years ago, and getting better at golf and
Yeah.
worse on cows. So.
Okay, very well. Jeff, why don't you just kind of give us an overview of the presentation that you're going to give tomorrow?
New research is changing everything we thought we knew about choline's impact on the cow and her calf, and top scientists have a lot to say about it. They are presenting new research that supports choline as a required nutrient to optimize milk production, choline as a required nutrient to support a healthy transition, choline as a required nutrient to improve calf health and growth, and choline as a required nutrient to increase colostrum quantity. This new research is solidifying choline's role as a required nutrient for essentially every cow, regardless of health status, milk production level, or body condition score. Learn more about the science that is changing the game and the choline source that is making it happen. Reassure precision-release choline from Balchem. Visit balchem.com/scientistsay to learn more.
Okay, so I was asked to talk about diet digestibility, so I'm going to go through some key aspects of what is in the diet and how to try to improve them. How we can improve starch digestibility a little bit. On the other hand, starch decreases fiber digestibility. Some tips on trying to reduce that depression. I'm probably going to step out on a limb and talk a little bit about fat digestibility, which maybe I'll have Adam Locke correct me on.
Yeah.
And then kind of finish off with a few things related to the total diet, especially with fiber digestibility.
Now, the one thing I liked about the title is practical steps. Kind of give us an idea there. You're gonna just kind of talk about some things that nutritionists can do practically
Well,
on
I'm
the
going to
dairy.
try to, but my handicap is really high on that.
Okay.
Worse than Bill's on
Is
golf.
that
So,
right? Okay.
so I'll try to do that and give some examples the best I can. And when I talk at these, I always try to provide the mechanism or something so that people can help to troubleshoot, not try to tell other people how to do their job better when they're doing that every day. So I'm going to try to help them to think a little bit about
Yeah.
what kind of scenarios they might want to try.
Yeah. Good. All right.
I'll start off. We've known this negative relationship between starch and fiber digestion for
Forever.
50 years or more.
Mm-hmm.
And if you look at that meta-analysis a few years ago, the depression starts at very, very low starch concentrations. Why do you think this is? It can't be a pH thing at that.
Yeah, I think the depression is probably only about half of it is pH. The other half is other factors that we call the carbohydrate effect. So it could be. I never really looked up where those, what kind of diets those were.
Yeah.
They could have been lower in protein, or, a lot of times, especially historically, people did things that are trying to set up. I'm comparing this to this, and they don't really think about
Mm-hmm.
the rest of the
Yeah.
diet so much. So it could be something like
Mhm.
that. But I feel like if we're going to help to make sure we maximize fiber digestibility, we have to have enough ammonia and amino acids. I'm going to talk a little bit tomorrow that there's sort of a dogma that the cellulitic bacteria don't need amino acids, but there shouldn't be. They do, and so we need to make sure we provide enough rumen-degraded protein RDP. So I think that's some of it, and some of it is they just displace the bacteria. They're just more. The more starch you give, the more our other bacteria, all swimming in the same swimming pool, trying to find a place to land, and so some of it's kind of that. So
Competitive exclusion, just
a bit
pushing
of
out the
exclusion, right?
fibrolytic bacteria.
Is highly digestible fiber more susceptible to starch depression than soy hulls versus cornstalk?
Actually, that's a point I'm going to make tomorrow. That probably the source that is the most susceptible is soybean hulls, or I didn't bring it up in there, but maybe something like corn gluten feed, something that has a really high extent of fiber digestibility. And we don't even think about it. When we design these diets, we try to lower starch. We add more soybean hulls, and we improve fiber digestibility. Yes, we did, but we lost some fiber digestibility because we didn't get all that we could have out of those highly degradable soy hulls.
Mhm.
So it doesn't mean you still don't have a negative effect. So yeah, I think they're even more prone. Exactly.
Okay.
I want to dovetail on the interaction of the starch and fiber a little bit because it c- if I remember right from a paper, I think it was a Hoover paper in the 80s, looked at hindgut NDF digestion versus ruminal digestion. And so, like, the depression effect of additional starch, is that just ruminal? And if it is just ruminal, then you would expect a ruminally degradable starch to depress that more so. And is that data out there? Has that relationship borne out?
Uh, wow, I think you're probably right that if we have really high starch and we depress fiber digestibility in the rumen, we probably are in the large intestine. But boy, that's hardly ever been looked at,
Yeah.
especially for dairy cattle. Placing an ileocannula in dairy cattle is really hard. I did that for a few studies, and I got tired of being called out in 3 in the morning.
Mm.
So, so it's really hard to know. But I think there probably is some of that. The more a cow eats, the faster the passage rate. That affects the rumen, but it also affects the hindgut too. So there's only so much time that's there, and the more you prolong the negative effects downstream, the less time you have to get proper fiber digestibility.
Right.
And in sheep, for example, it's probably the opposite. They have a longer large intestine. There probably is more opportunity for compensatory fiber digestibility. But that's just a guess, but
Yeah.
yeah, it hasn't really been done.
Do you think, there's data again showing high protein diets well in excess of requirement improves dry matter digestibility significantly. Do you think you'd see the same thing with urea? I get that question a lot is can I feed urea, meet the RDP requirement and still get all the benefits of say soy RDP or some other RDP source?
I really don't think you can. You could, if you really are suffering from a rumen ammonia deficiency, and then urea is a good way to go. But like I was just saying at the beginning, the cellulytics, they don't just need ammonia. I know there's sort of the dogma that they do, but they need actually amino nitrogen, probably not just the branch chain ones, but also probably phenylalanine and weirdly maybe even proline. It's kind of potentially limiting one. So I think they need to have natural RDP, not just that, not just urea.
Okay.
What is our knowledge on what those requirements would be then? If we're looking at, say, just looking at branch chain amino acids, and if you mentioned phenylalanine, how comfortable are we with saying, okay, we probably need this much for the rumen in addition to what we're thinking about for what we want the cow to receive?
It's a little bit of the Wild West that we kind of don't know. So, we draw from in vitro kind of studies that to try to extend it to what is needed in the cow. But, to a certain extent, it's really hard to do because they mix up the amino acids. They break down and provide mixed carbon skeletons, and then they make what they want out of it. So you can't just feed, let's say, lysine and see does that improve digestibility or does it improve microbial protein. So you kind of have to look at them in a combination, and that work really hasn't been done, but I think it should be. I think there really is a need for at least some of them. Could be that methionine could be limiting in some cases, believe it or not.
In the rumen, you
In the
mean?
rumen,
Right.
yeah. And and it probably depends on the microbes that are there and so on. Like methionine is something that when people study fiber degradation and use pure cultures of cellulytics, they always put a little bit of methionine in because they know that it helps them to do their job better. Phenylalanine. So, yeah, but to your question, Bill, we, we need ammonia, and it's more important than the other amino acids, especially for the cellulytics. But that doesn't mean they don't need the amino acids. If we're trying to get the most we can out of them, fast passage rate, they have to be able to, stay with that, keep breaking down fiber, and especially the better quality fiber that we feed. We want that broken down. We want the energy from it. We need to, sort of beef up how we feed the fibrolytic microbes in the rumen.
What about sugar? You've worked on sugar almost your whole career at OSU over time. So is it better than starch with respect to total diet digestibility?
So I'm actually talking about that a little bit tomorrow. There are some studies that show that sugar improves fiber digestibility, and you have to ask why. And I actually went back to some of the sources on that, and I think some of it is that probably sucrose, believe it or not, can be used and possibly could help some of the cellulytics. So it could be that it really does work in a way like that. But part of the aspect that I'm going to talk about tomorrow, when we say sugar, a lot of times we're adding like molasses.
Well,
Molasses has a lot of stuff in it besides sugar.
yeah,
And it could be that those components are really, helpful as well.
Does it matter what kind of sugar? Glucose, sucrose, fructose,
So people have actually done some of that. There's
lactose?
a few studies with sucrose where they've added it and it improves fiber digestibility. It could be that it's the fructose part of it. So I wouldn't be surprised about that. I think it's probably not just glucose or maltose. Those seem to stimulate the the ones that break down starch, the amylolytics. So I think probably the sucrose one could be lactose. I get asked about lactose a lot. it could be that that helps them out too. There just hasn't been as much done with lactose as with sucrose.
Before we get away from the carbohydrate discussion, I had a question about at least one of the most practical things I can think of when I talk to farmers and nutritionists is corn particle size, grain particle size. What what do you think that particle size needs to be in a diet? And because I think we're in a trend of smaller is better, smaller is better. And is that the case, or is there a floor to that number we should be shooting for, or what do you think?
So I've always, I won't say always, but for a long time I've been thinking, well, we might as well get the most we can out of it. It takes some of the guesswork out. If you have a coarser particle size, then you're sort of wondering, is it vitreous or not? What will the digestibility be? Let's just put it out there and then feed not quite so much starch. I know maybe that's not a good thing to say. A whole bunch of people from a certain state that
I think I know what you're hinting at.
maybe you need to cut that one. I don't know. But I think it's we can feed rumen-degraded starch, and that's what we should be balancing for, and some of the models are trying to do. And then we optimize the best we can without overdoing it in there. And then we can also improve digestibility or energy with better quality forage, soy hulls, stuff like that, and the proper amount of fat. So, and feed intake.
Kind of building on what Kirby was asking, is there any benefit to maybe having multiple sizes of you got your finely ground corn, maybe some medium ground, so that it kind of levels out the availability of the starch in the rumen?
Uh, yeah, you can't. That would be a good thing to do if we could project what the overall digestibility would be. But the more variation you have like that, I think it's harder to guess it.
Got it.
Like if you have the more vitreous kind, if you grind it really finely, you can take away the vitreousness of it. And so if you had more moderate particle size of a floury kind of hybrid, then probably would do pretty well. So I don't know. I I sort of feel like we want to grind finer, but we don't want to have a bunch of dust either.
I mean, we
So
have particle sizes out there now at sub 450, sub 400 micron in some cases. I mean, there's some pretty dusty corn getting fed to dairy cows out there.
yeah, I don't think we want you know something like that could be unpalatable, but um, you know, like I always kind of thought like you think about we send all this corn to California and then they steam flake it all. And well, when you steam flake it, you know what you have. It's the same every time. You take some of the guesswork out of formulating it to provide the right amount of starch in the diet. And then when we grind it, there's a lot of variability. Well, if we can reduce the variability, to me that seems like a good thing.
I think I would agree. I know NASEM has a discussion in there about grain particle size and grain source on the fiber digestibility depression, and I think it's a question we have yet to address.
So I think everybody would agree we should formulate for rumen fermentable starch. How do I get that number?
Yeah, that's. I actually did a study where I did formulate that, and it seemed to kind of work along what I had projected. But where do you get the numbers for that? That's a tough one. It's as you know, I've kind of been talking about like doing duodenal cannulation versus like now everybody does omasal sampling through the rumen cannula. You kind of get different numbers for starch, and that's kind of making it really hard to come up with here's what this rumen-degraded starch value is, because it depends on which system you use, and we don't know which one's right. So ideally, we would do that if we could come up with cohesive values for that, then it would be ideal. I don't have a good way to do it. So many people feed corn and they don't measure the particle size, like you're obviously doing now, Kirby. And they just say it's coarse. I rolled it, and then I've seen some papers where they do report the particle size, but I can look at the distribution and say, well, they obviously did something wrong, because you can just look and say that can't be right. So we need to do a better job of educating our researchers. If you're going to do a study, how hard is it to do corn particle size? It takes 10 minutes. Your student learned in a half an hour.
Right.
It's not hard. We should be doing it. Then the meta-analyses will come out good. Like in NASEM, we had a really hard time trying to predict rumen starch digestibility because there was so many imbalanced studies. Like I still remember this, doing this work, and it kept saying that barley starch digestibility was lower than corn.
Yeah.
And of course, we all know that can't be.
Right.
And I went and looked at, and because the studies where barley was added, like one of the studies with barley was added to a diet that had corn silage in it, that was 49% dry matter. What do you think the starch digestibility of that corn silage was? So it brought everything down. Then it makes it, when you're looking at barley versus corn, it's like barley's low. I mean, it's just really hard to do that stuff. So. But ideally, Bill, if I could do that, if one thing that I would do if I had, my magic wand, I would do that. I would come up with a cohesive way to say this is a good estimated rumen-degraded starch.
There's some labs that measure it differently, but they give something called rumen availability, different names. But does that have any? Has anybody looked at? Does that lab value have any relationship to what you're trying to formulate
Yeah.
for?
So I've been in. I've talked like with Mike Allen a lot about that. Of course, he's retired now. And the lab values, they definitely rank. So if somebody is looking at a diet and then they send off the starch sample, and it says here's the 7-hour digestibility. If it's higher, we know it's higher. If it's lower, it's lower. But it's more of a ranking tool.
Okay.
We know doing that in vitro is really really tricky research to do. You overwhelm the system. It's not even, you can maybe manage pH in it, but the microbes, they break down the starch, and then what do? They turn it into like this extracellular stuff that measures as starch.
Yeah.
So what does that mean? So I understand why we do it. It's valuable, but it's not going to give you the absolute value, I'm afraid.
It gets us part of the way there.
It gets us part of the way there, and it's better than not doing it. Fecal starch, same thing. I feel like if you get more digestibility in the rumen, you're going to get more digestibility in the total tract and less fecal starch. So it's a good ranking and troubleshooting guide. If I were in the field, I would definitely be doing that.
Okay. I'm going to switch gears to fat. Ruminant fat, NASEM says it's average about 75%, give or take a little bit, which for all species, that's really, really low. What is it? Is it analytical issues to, is
The
it
digestibility,
apparent versus true, or is it something biologically limiting fat digestibility in ruminants?
I think there is something limiting biological fat digestibility, no doubt. Pancreatic lipase is going to be less because the rumen microbes just, chop off all the fatty acids. Why would they need it? Evolutionarily, why would they need it? Unlike a pig that has all kinds of it. But some of it's beyond that, like the typical ways that work with lipase, and my cell formation, we've kind of reduced those. So like phospholipids that are in the diet, some of them can help to emulsify fat in the intestine, and the microbes break them up. A monoglyceride, like a pig eats a triglyceride, it retains a monoglyceride. That helps as a detergent to emulsify. So one of the things that I think I've sort of projected is that probably part of the microbes' cell walls, as they're being broken down, they probably help to emulsify the fat. They help the animal to improve fat digestibility. And so I think no doubt there's kind of a limit. You start feeding too much fat, and that limit's way lower than unfortunately for us people. So yeah, I think there probably is the digestibility, but I'm going to talk a little bit about we've come a long way at improving it. I mean, since I remember doing this first study on partially hydrolyzed hydrogenated fat,
Oh, yeah.
and somebody telling me they fed it and then they kept slipping, because it got excreted out and was slippery. So we've come a long way on that, and the companies have, really, really stepped up. So, people like Adam, those values are a lot better, and we can get more energy in that way. Um, I'm going to talk tomorrow a little bit about why I think some of the fatty acids, palmitic and oleic, probably help the microbes. They probably can take them up and potentially even improve fiber digestibility. So Adams and his group have been talking about it. Probably, maybe you had something to do with that, Kirby, but everybody kept scratching their heads and say, well, that can't be right. But I think there's a real reason behind it, a real mechanism. And we should be trying to explore it and potentially, use that opportunity.
And there's actually some neat data out of, I think it was University of Utah, or Utah State University had an in vitro study looking at palmitic acid, and it also bumped digestibility pretty clearly. And they were looking at some microbial fractions and microbial phospholipids. I think it was a neat data set that echoed a lot of what Dr. Locke has seen.
Yeah, I'm going to go through a study tomorrow from Florida, but there's others. Ben Wenner has done a study that shows the same thing. It's pretty consistent.
Mm-hmm.
Any thoughts on how much you should supply to the rumen as opposed to bypassing the rumen?
Well, the thing with palmitic acid, a bunch of it does kind of bypass, but it's more soluble than stearic acid, 18O. So enough of it kind of like bumps into the microbes, and they probably are able to sort of adsorb it. Then it kind of like moves through their membrane, and then they can use it. So, pro, s I'm going to say tomorrow. Probably you've heard that many times today. Probably the best way to improve fat digestibility with blending palmitic and oleic is probably the best way for the microbes to use it too. That's
Okay.
about the same proportion they need. So kind of just works out that way.
Yeah, interesting.
So, 1.5, 2% of that kind of fat is probably has a potential to improve fiber digestibility.
I know when I was in school taking lipids from Dr. Palmquist, it was everything was fat was negative on NDF, and it was different fats back then. But I can remember lecture after lecture on how you have to incorporate the depression and fiber digestion when you're doing the economics on fat supplementation.
That's really interesting you bring that up because remember in NASM we kept talking about it and like Lou Armentano
Yeah,
was bringing up, well, a lot of those studies they fed a lot of fat because they were trying to prove something. That's what we do when we design studies. We want to see a significant difference, so we put a bunch in. But when you do kind of a moderate amount, it usually doesn't depress fiber digestibility. And before you start depressing fiber digestibility, you're probably going to, do something to milk fat or whatever first.
Mm-hmm.
So a moderate amount is probably not bad and probably good.
Now, has that improvement in fiber digestibility with very specific fat feeding, has that been seen in vivo or is that mostly in vitro work that?
Both. Like I don't know how many studies Adam has. More than 5,
Mm-hmm.
unless maybe not 10, but he's got a lot of studies. Repeatedly, palmitic acid blends improve fiber digestibility.
Yeah, pretty stable 2 or 3 points, I think, is the
2 or
bump.
3
Yeah.
points. Yeah, that's about right.
Is there an advantage supplying that in the fatty acid form as opposed to triglyceride, free fatty acid?
Free fatty acids.
Yeah.
Yeah,
Okay.
I think that's what you want.
Yeah.
In your paper, you talk about excess RDP being negative or potentially negative on fiber digestion, which I thought was interesting. What do you think the mode of action of that of excess of?
Of course, excess is a lot.
Yeah,
like
but
20, something
it's
like
not
that.
practical, but
It's not
still.
practical.
But why would that happen?
That's a really good question that I want to ask your former grad student who actually did that, Dave Jones. So I'm just guessing that you sort of are tilting to the wrong grouping of microorganisms so that they don't work together as well as they should. One of the things we're really finding out is, so having worked with a bunch of really high level microbiologists, the kinds of microbes that you have in there is more complicated than we think. There's more of them within a species. There's differences in the kind that they are, and there's some that sort of work together. And the ones that work together, that's the best way to break down fiber. And you start tilting it away from that, and then they just start losing out because they just don't have. I just say it's like we're driving around here. They don't have a parking spot to initiate their colony, and then next thing you know, they're out. So I just think it's a tilted population.
So we know that we need some amount more of RDP going in as we improve starch digestibility. That's kind of something that you've established a bit too. So can we just classify that as RDP? And you've talked a little bit about the amino acids, and we obviously don't know the requirement there, but if we just say 10% RDP is where we want to focus, or 9% RDP, is that getting us by enough to keep fiber digestibility where we want it and coordinate with the starch, or kind of what are your thoughts on?
Um, Another thing that I think you hit right on the nail right on the head. We need to have adequate RDP for sure, and if 10%, maybe potentially more if we have really highly degradable diets, really good quality feedstuffs. And then if we could, we would start looking at the kinds of degradable amino acids within there. And like all the systems, they assume every amino acid is degraded at the same rate. And of course they're not. Probably the branch chain amino acids are degraded at maybe a little bit different rate, and so on like that. So that probably is exactly right. I think phenylalanine is a premium one for fiber degraders. Over and over, the in vitro studies show it, but it hasn't been done in vivo, so we don't really know. But I think we'll be moving toward that if we can get systems to be able to do that. I feel like we need to do amino acids. Nobody does amino acids in their studies anymore. If we would start reporting amino acids and doing a better job of that, we would be able to develop systems. Like in NASEM, I looked over and over and tried to find every single paper with amino acids, and the studies aren't very well balanced. One will have soybean meal and this one, and then the next study has something else. You have to have overlap across the studies to be able to have them all fit together. If you don't, then you just run into pockets where the fitting processes don't work very well. So, but yeah, I think we'll find that in the future if we look for it.
We've talked about this over a long time. There's studies showing, again, very high RDP, 12, 13%, and well above requirement. Intake keeps going up. Is this, do you think, a digestibility thing, or is it something else?
It's more. Some of it is related to fiber digestibility and reducing the fill limitation. So like that you were talking about there, they digest more, the cow can eat more because it's got more room in the rumen. Room in the rumen, that's a good one.
Trademark Firkins.
Yeah. Cha-ching. So some of it's that, but in other animals they find the same thing. I had this conversation with Chris Reynolds 20 years ago when he was at OSU. They did a study one time where they infused ammonia into the blood, and it increased intake. There's something about that. uh, the body is trying to resolve, do I have enough protein and so on before I want to do the other things like do I have enough to make more milk or whatever. So I think there's more beyond just what the rumen that's going on. And like I said, with other, like with pigs and so on, they find the same thing. It's not just getting more, but maybe a better balance of amino acids in the blood. There could be some way they're sensing that. So yeah, I think that's, and the flip side of that, Bill, if we start not having enough, we probably are more likely to limit feed intake. Maybe not just because of what's happening in the rumen. And then as you brought up, especially as we have more rumen-degraded carbohydrate, there's more energy for microbes to grow. They need more RDP. So we should be formulating for it. You brought up Will Hoover. He used to have a sort of a thumb rule of so much non-fiber back when before we were measuring starch to RDP ratio. There's those kind of relationships. They're there, like the models are trying to account for them. But no doubt that's an important feature.
I had a question on the RDP, kind of a ration balancing hypothetical. You know, a lot of the research that gets done in dairy nutrition is done in the upper Midwest and the Northeast, where we're feeding diets that are 18 to 24 forage NDF. And I've got to know a few nutritionists out west. You know, they're oftentimes feeding diets with 20, 30% forage, 10 to 12 to 15% forage NDF, you know, that are going to be rapidly passing through the rumen. Do you think that changes the percent dietary RDP that they should be targeting? That maybe, you know, would make that more optimal?
Oh, that's a good question, Kirby. You know, I don't really have experience to go along with this, so I'll just speculate, and you can decide if you want to keep.
That's what podcasts are for.
Yeah, there you go. uh, I think probably the more digestible things are, the probably the more RDP you need to have. The thing I have talked with people about in the West that you didn't mention, there's a lot of soluble fiber, and we don't do a very good job of measuring it and figuring out who's breaking that down. I can tell you that the microbes that break down the soluble fiber, like pectins and so on, they probably also have negative effects from starch. So, you know, if you're limiting starch in the kind of diet that you put together like that, that's more opportunity for them. And we need to make sure we're providing the same nutrients like RDP or other growth factors. So soluble carbohydrates are really a neat thing. That's been looked at somewhat by people like studying like cows eating pasture, where there's lots and lots of that. And so just extrapolation, I would guess that there probably is a relationship in there. Maybe not so much fill oriented.
Right, yeah.
And of course, you know, the flip side is when you have a lot of highly degradable forage, you need to have enough rumen compaction to be able to filter those and keep them in the rumen. Otherwise, they just keep on going.
Right.
Any other key points that you plan to cover tomorrow?
Let's see. I can't really. You guys kind of stumbled across all these things. So Bill did his homework. I don't know about you other two, but I see he's got a piece of paper there. Pretty much that's going to be the nuts of it. I just got to try to shrink it into 30 minutes. So.
Yeah, yeah.
Well, I did want to ask one more question. Your student brought it up yesterday in their presentation about peptides and the role of peptides in the rumen, and I was kind of just wondering if you could expand on that a little bit, because it's a story I think needs developing.
Okay. You know, so peptides are, first of all, you love them and you hate them. There's no good way to measure them. I remember, like in my multi-state project, talking about this, and so there really hasn't been a good way. One of Glenn Broderick's former students had done this paper where they used this ultra filtration that you can separate by a molecular weight. At least that's consistent. All the other ones depend on the hydrophobicity of peptides and so on. So people are getting peptide values all over the place, and it depended on how they did it. Now there's a way you can actually measure it. So I'm actually kind of excited about it, and it seems to work pretty well. So all the microbes in the rumen, you know, not all of them break down protein. The cellulytics don't do that very well. They have proteases that they need for their own internal functions, but they don't break down feed protein very well. And so they rely on other bacteria to do that, and protozoa. And then they feed them ammonia and the other stuff that they need. Well, the bacteria that break down protein mostly are like starch users. And so what's encapsulating starch granules? Protein. They have to have proteases to get what they want. But they don't have to have all the peptidases to break down the protein that's been partially broken down. They don't need peptidases unless inside their cell is telling them they need more amino acids. Go get some. Go upregulate peptidases. So they seem to be very, very much under gene control. Our models, we assume that it's constant. You put some protein in, RDP is the same no matter what kind of diet. Well, it probably isn't. And so, we know that there's some soluble protein that passes the rumen. It's probably all peptides. It's not the actual protein so much, it's the peptides. And then, so we're kind of looking at as what kind of situation would help them to be broken down more. And it does seem to be interacting with the branched chain VFA concentration. So that's what she presented. So I think we need to go back and, this work hasn't been done since the 80s and 90s when you guys were talking about when you were born. But they did some great work back then, and then molecular biology, came into play, and it was a whole lot easier to do that. So I think peptides are going to be a part of the future in dairy nutrition research. So I don't, without going into a bunch of science there, I think it's really exciting. We should be doing it more.
Got a lot to look forward to, Kirby.
I think so.
Good, good. As we wrap up here, what I'd like to do is just for each of you to kind of come up with a couple key takeaways for the audience, and we'll just kind of go around the horn. And would you like to start over there, Laura?
Sure, Scott. I'd love to go first on that one.
Tonight's last call question is brought to you by Niasure Precision Release Niacin. Niacin is a proven vasodilator for heat stress reduction and a powerful antilipolytic agent for lowering high blood NEFA in transition cows. Protected with Balchem's proprietary encapsulation technology, you can be sure it is being delivered where and when your cows need it. Learn more at balchem.com/Niasure.
I think for me, the biggest key takeaway is thinking more about that RDP and amino acid requirement that we have for the rumen, and to really start incorporating that in and taking into account the amount of fermentable starch, and how as we improve the amount of fermentable starch, that we need to think about the fact that we're going to have a larger demand for RDP and specific amino acids. So I think just keeping that in mind, especially as we formulate for specific amino acid requirements of the cow herself, that we need to not forget about the rumen as we're doing that.
Yeah, that's a really good point, and I would say not just rumen fermentable starch, but soluble fiber and really highly degradable fiber, like that's with really good forages. I still kind of come back that the cow evolved, to break down fiber.
Mhm.
And, we should be optimizing that. I think that's the best way, that when we break down fiber better, we're going to get more milk fat, we're going to have higher intake and so on. And so a lot of what I'm talking about tomorrow is going to be related to factors that affect fiber digestibility. But it's as Bill said, we've been talking about it for 50 years. We've improved, but there's still, quite a ways to go. So,
Yeah.
I think before I'd give my final take home, I wanted to point out, I was like, this is the great part about having someone who's new to the Buckeye family and getting a chance to work in this place. The chance to work with the likes of Dr. Firkins and get to know Dr. Weiss is like just catnip for a young scientist who try to absorb as much as can. So I want to thank both of you guys for mentoring me along as I've transitioned into this role. But my takeaway is something I've heard both of these guys say, is that diet formulation is not just putting something in, you're also taking something out. So you got to take that whole picture into consideration. It's not taking out starch or just adding starch. It's taking out soy hulls, or it's taking out a little fat, or it's putting in a little forage fiber. It's a calculus that we have yet to really understand.
Great comments. Bill?
I think, we need to remember the limiting nutrient for milk is still energy. It's been that way forever. And so these little changes, 1 or 2% change increase in digestibility is huge.
Yeah.
And we forget that, and so all this emphasis on all these little details that they matter, even though the actual change in digestible energy might be small, but if it's the limiting nutrient, you will get a response. So
Yeah.
again, it comes down to fiber to me. We've done a lot to improve digestibility of everything else.
Yeah.
We talked about fat. We've improved that digestibility. Corn, fiber. even now, it seems like we add 1% more starch, we take away a quarter of that we give back because we're losing fiber digestibility. Do we really want to do that? We should be able to find a way to limit that we give back, that winds up, in the manure pit and makes methane or whatever. We should be able to improve it because we can, and then try to get cows to eat more and have just a little bit better diet along the way. So yeah, that's what I'm going to try to hit home tomorrow.
Yeah, good. Looking forward to it. So I think that's a great stopping point. Jeff, this has been enlightening and it's been a lot of fun. So I want to thank everybody for joining in on that. This has been good. Laura, thanks for joining us here as the co-host. You do a great job.
Thank you, Scott.
Even though you
Pleasure
guys
to
are
meet
so
you,
young,
too.
you guys do a great job. But Kirby, thanks again.
Thank you.
You're a rising star. Appreciate you. Bill, as always, it's been great.
Yep.
Loyal audience, thanks for coming once again. Hope you learned something. Hope you had some fun. Hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email at anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars takes place on the first Tuesday of every month, with the top research and nutrition topics that will impact your business. We also include small ruminant, monogastric, and companion animal-focused topics throughout the year. Visit balchem.com/realscience to see the upcoming topics and to register for future webinars. You can also access past webinars and search for the topics most important to you.